Who would like to go first? Get Aaron. Aaron, it's you.
Sure. Okay, I'm I had to put this headset on. I can hear it a little bit better. That way, can you hear me all right?
We hear you perfect. Yes.
Awesome. Okay.
Would you like to see what we look like? Have you seen the group?
Well, perfect. Okay.
James wants to know where you are.
Right now, I'm at Argyle Centre.
Okay. Hey, it's all yours. If there's anything I can do to help, just say.
Okay.
I'm going to go out of the picture.
Okay, I didn't prepare anything too formal. Just kind of talk about the kind of printers that we use in the program and where we use them to meet different curricular objectives. So Argyle Centre, for those of you who might not know, is basically an alternative learning center. We do online learning, schooling. We have the Caraway program, which is a mix of grades 9 to 12 right now at the senior level. I work with them. And through Argyle, I work at a number of schools across the city, mostly in high schools, Ross Shep, Harry Ainley, Queen Elizabeth, Wagner a little bit, and here and there. So I'm all over the place. Argyle is, I call home most of the time. So I put a number of printers in here, and sometimes I take them out to other places. We started off a number of years ago with, sorry if this is going to make you dizzy, I've got stuff all over, so I'm going to be walking around here. A number of years ago, though, we started off with an Alta Maker, which we purchased from the Netherlands, and it has been a very effective printer. It's got a heated build plate, uses filament that's about 3.0 millimeters. They've got an excellent support network, so should we run into any challenges with operating the system, they're pretty good at walking us or getting us through any problems that we're having. Moved into MakerBot Replicator 2s, and we have a few of these. I keep one at Queen Elizabeth High School because there's quite an interest group there that I work with every Tuesday and Wednesday morning. We keep one of those at Argyle, and I let students make modifications to the structure to make it more efficient. If we want to print in different colors, we have built these towers. The students have printed those. I think they just got them off of Thingiverse, and then they bought just some doweling there to put different colors on so we can change them out quickly in a print if we want more than one color. We use 3D doodlers, which I just bought at Michael's, just because those tend to be more engaging for the younger years. Printers can be fun to start up and watch for a few minutes, but then the younger years quickly get bored. They like the 3D printing doodlers because they can make stuff with immediately by holding it in their hand. So here's some glasses that somebody made. It's kind of fun. The other printing that we do is we have a, oops, this door is locked. Sec. A LoseBot has 5, and I'm locked out of this room right now, so I can't really show you, but this is a dual extruder. So we can literally print with 2 colors without having to pause a print and change out the filament. And the dual extrusion is pretty interesting. Sometimes it can bunch up and cause problems, but as the technology is evolving, we're going through, this is our learning curve. So I try to provide students with as many possible opportunities as I can to explore this this up and coming technology, which, according to the World Economic Forum, is going to be in every household and business in the next few years. So as a skill set, I think it's pretty critical to integrate them into schools at all levels. Okay, some of the things that we've been printing. We work a lot with, can everybody see that? There was kind of a couple different things. Maybe all I'll do is just hold up a few things. Probably making you guys dizzy moving this around a lot. We've really been into using 3D printers for a couple of different purposes. One is it's focused on sustainable development. We do use the PLA or the corn-based plastics as much as possible. We're trying to decrease the amount of toxic particulate matter that gets put into our air. We don't really have fume hoods here at Argyle, so we can either print in closed rooms, small offices, or by windows if we want to use ABS filament, but generally we use PLA. It's a lot safer. So the sustainable development aspect of the program focuses on local manufacturing, 3D printing as a concept of local manufacturing, meaning that students are learning to rely less and less on the industrial machine for everything that they need, and use 3D printing to design or borrow stuff from the universal 3D printing community from places like Thingiverse to access prints and make what they need. We're also trying 3D printing scanners so that if I break my glasses and I can't quite get the exact design, I can at least scan them. And the scanner isn't here right now, so I can't show you that, but basically it just spins around, shines a light on it, and you can print from the scanner and get your exact object that you're looking for. The other key thing that we use the 3D printing for is humanitarian initiatives. That's, I think, a critical piece to integrating these into schools. Students want to learn more and do more when they know that their learning leads to direct actions, especially ones that are helping other people. So we've been printing, learning about prosthetic limbs and trying to 3D print them, and then getting involved with international organizations that we can deliver the products through and get to people that actually need them. So over or just before the holidays there, December 16th, we held our first Edmonton Handathon. We spent about 800 hours of printing pieces to build these prosthetic hands. And then we had a day, a practice day with our partner organization, APEGA, to learn how to assemble these things so that they'd be effective for the people that we wanted to give them to. And then we came together with 30 some students and 15 members of APEGA, and we built 20 some of these hands. I'm going to try to do a screen share here. See if I can find this. Oops. We just have a number of students there and a number of different community partners working to build all these hands. I'm just going to cancel out of that. Sorry. And so these hands, what's really fun about these is that these are sized to actual people's needs, and the colors are made to their specifications. So some cultures are particularly sensitive to flashy colors. Especially the children in Vietnam, they don't want to stand out, so they preferred certain colors like grays and blacks and browns. So we would purchase filaments specifically for that reason, and then we would print these pieces and then bring them together and assemble them. What else can I tell you about our program? So I do this through, I got to back up here. I do this through a program that I've created called Innovate, and Innovate is basically a hands-on project-based program that supports learning in real-world contexts. I don't focus on pedagogy. I don't have an actual classroom. I just work with teachers and students at various schools, as mentioned earlier. But we use a educational theory called andragogy, which is just a student-centered approach, and based on the adage that it takes a community to raise a student. And so we even though 3D printing meets a number of curricular objectives in all subjects, what I really like about it is its ability to bridge the different curricular objectives in the different subject matter. So instead of fragmenting learning in social studies, English, science, and math, we have an opportunity to bridge those things and make learning authentic and meaningful and very enjoyable. So one thing I've noticed with the 3D printing and students' performance in school is a lot of students tend to be more present. Students that weren't present before, maybe that would fall into the at-risk category, are now coming to schools consistently to 3D print. I've noticed students' math scores going up overall, and I believe that that's from using numbers. You know, when you're programming or you know, adjusting settings for the printing in, you know, say MakerBot, it's all ratios, you know, working with densities and, you know, for the infill, et cetera. And I think that just that natural day-to-day working with numbers has gotten students used to it and thinking and realizing its importance. So that's pretty exciting. Of course, the hands that we've been using, not only, you know, we had to use a lot of math, but a lot of physics as well in here, right? We're looking at the ability of these hands to do work. And it's a living social studies experiment, because when we give these to people, we can see how it benefits their lives and helps them integrate into the communities and do things similar to other people around them. Last year, we did a similar event in Calgary, and we actually built a hand for a 4-year-old girl named Clara. And I had published some of the pictures around the district. I'm not sure if anybody has seen them, but Clara, for the first time in her life, could hold a book by herself, something that we might take for granted with 2 hands. And she could now hold the book and turn a page. And for her, that was a huge change in her life. Also, by adjusting the tension on the back here, she was able to grip a handlebar and now ride her bike with her training wheels. So it was you know, really incredible to see that. And from an English curriculum perspective, students are so excited about their work. They're always talking about it and communicating, and I've had them present at a number of different conferences to showcase their work. Students are always at open house, talking to parents and prospective students coming to their school about this opportunity and getting more and more people excited. So on that note, are there any questions about what I've mentioned here so far?
I think we're good.
It's cutting out here.
Okay. I'm going to turn it over to Jason. Thank you so much, Aaron. That's
Okay.
great to hear about the vision and the reality of what it really looks like. Thank you so much. So, Jason, I'm going to turn it to you.
Okay. Well, thanks for having me here. That was great, Aaron. It was nice to see all of the prosthetics and different projects you guys are working on. We've done a little bit of that, but not to the extent you have. And working a bit with Mark over at Queenie, and he turned me towards one of his former students who was helping us out for a little bit before he went back to South Korea. Yeah, cool opportunity. So I'm going to speak a little bit more on the do-it-yourself printers, and that's where I have trial by error experience. And I've started a PowerPoint here, so I'm gonna share that with you guys if I can figure out how to do that. Oh, there we go. Okay, can you guys see that? Yeah. Yeah. Okay. got a lot of pictures in here, so I kind of made it in conjunction with that list you gave us about questions. Why I got into 3D printing. I love reading about technologies and entrepreneurship. I actually accessed the staff development fund probably about 2 years ago when it first came out, and was able to buy this first 3D printer that you see here. That's no longer available, as they found out you can't buy technology with the staff development fund anymore. I'm sorry if I ruined that for anyone who was hoping to do that as well, but and this printer's based on it's called a RepRap 3D printer. I love the idea that you could start printing parts for a printer. You could. My initial idea behind it was if I could print all the parts for a printer, and then I could share it with one other school, then maybe they could start printing the parts for a printer, and it would be that pay it forward type of project. As you can see in here, I became broken, and unlike what Dennis was talking about with the MakerBot, there wasn't that support, and I'll touch a bit more on that. So I learned how to weld acrylic, set up and get it working again, and just have some pictures of some botched prints and some of the things I've gone through. So this led me to a group printer build last year in March. About 20, I think it was about 20 schools came, and most teachers brought 2 students. Schools with just teachers, but it was a really great opportunity for my students as well. You can see a couple of them, in the bottom corner here, and in the center of the picture, they started building the printers ahead of time so they could help troubleshoot day of, and that printer build went 2 days. We had, and Dennis and Tony, you guys could correct me if I'm wrong, but maybe 3 out of the 20 printers that were totally functioning by the end of that. So it was a bit of an experiment, but really powerful to see teachers working alongside their students as students. And this was the type of printer I used. So it's based on a Cruza I3N, and you might have heard of this, or you might not have. And these are the Cruzas on the right side of the screen. It was the same idea that kind of got me interested in printing. Was this I think his name's Mendel. He started building these. He built his first Cruza, and he shared it all open source. Shared all the plans. You can find them anywhere on the internet, and wanted to help people build their own printers. And as you can see, most of the parts, most of the components are printed. The frames can be built out of plywood, out of steel. Mine are built out of acrylic mainly. I have a picture here of 2 of the printers I've built. Not one of the ones from the printer build day, as the printers I had got used for parts in other printers. I haven't replaced those yet, but these are a couple of them. And this, wondering how they can include this directly in their classroom. Is I'm fortunate enough to have a principal that he bought this steel cabinet. It's right behind my desk at the front of the class, and it prints as I'm teaching, and we have it running. Kids will come up and watch it, and yeah, it's neat. You don't have to have this separate. And I also use PLA. I have not printed with ABS. I haven't found that need yet, and just having it in the classroom, I was always a little hesitant to give that a go. So I teach French mainly. Also an innovation and design class, my shop class. We've started a genius hour at our school, so every Tuesday morning students have a block to work thing that they're interested in learning. And then as well, we participate in the I-Cubed program, the Investigate, Innovate, and Invent through the Learning Partnership. And these are mainly on this side of the screen, mostly things that you'd find on Thingiverse with a bit of a finger splint down here, and that was modified. These were just kind of seeing what the printer could do. This was a real hit, as it you can print 3D objects, as many of you know, in one print that has moving parts. So these are ball bearings, and it kind of spins on 3 axes. But over on the left side here, this was a fidget that one of my students printed, and I've had a lot of success with students designing simple things for them to keep their hands busy in classes. And then we've gone into everything into these were for mousetrap cars, these wheels down here, and even some model work, stop motion photography. And I should mention, we're an arts core school, so it really does allow me the flexibility to use project work with my French classes, and working on integrating that into the core classes as well. So with my printers, they're all open source. I like the open source. I like the idea of people sharing, and there not being any barriers to that purchasing. Also cheap, you could say. But I use, so these are slicer programs. If you don't know, they'll just slice your objects into layers once you've either designed them or downloaded them. Dennis spoke also about taking raster images, either drawn or from photos, and converting them into a vector image, or in this case, an SVG. And I use this site; it's free. It's worked pretty well, and it can give you some funky results and some your original image. Primarily Tinkercad. We have a set of Chromebooks in each one of our classrooms, so I find Tinkercad, as it's web-based, lets all the students sign in. There's another program now that I think of it. I think it's I'll have to remember that, but there's another program that students can sign in through Tinkercad, even the grade 7s who are under the age of 13. And it's sort of like a Google Classroom, so they can sign in, and as a teacher, you can give them Thingiverse. Another good one I found is Mesh Mixer, and you can take objects and create your own support with this. You can also, as an arts core school, we've played with kind of molding shapes like clay. So once you have an object in there, you can really pull and tease the surface of it and make surfaces turn into honeycomb structures and things like that, and it for people to play with. FreeCAD is a math-based designing program that, again, it's free. I'm not sure it downloads on Chromebooks, but if you have a computer lab, this is an interesting one, especially maybe with the high school level. Students working with numbers and designing specific parts. And then my favorite one is Fusion 360. I'm not sure of on that for school programs. I use it as just a teacher, and it's a real professional program, and you can do some really detailed projects, and it provides rendering and all sorts of things. And then finally, as I stick to the free concepts, Facebook groups I found for all of the printers. You can join any one of these Facebook groups and tap into a network that's global, as well as YouTube is that's what I turn to. A couple other resources, the Invent to Learn book. I hope many of you have seen it, and they also came out with a 3D printing booklet that supports the lessons and the ideas in this book. I handed these out with each 3D printer when we built them, toolkit. And then Make Magazine or Make Zine, just a great resource for making in general, not really specific to 3D printing, but they have a lot of good material. You can check out their website. And so with my do-it-yourself printers, I have a lot of problems where stuff jams up, stuff might not be working too properly, and you have to troubleshoot it on your own. So I spend a lot of time with students. They create designs, they experiment with structures, and we break it down if they would be easily printable on our printers. Why not? Their design might work or might not work. All through Tinkercad. So I've had students design entire kitchens during our shop class with cabinets and plates. And here's just some examples of students using, these are 3D printed bases, and he didn't go as far as to print all the organelles, but it kind of shows a mix between technology and some other arts. And to speak a bit about this house, this was something one of the math teachers in our school and our principal were working on, and it's 3D doodler. And the initial drawing was done on grid paper, and it was a grade 9 math project that for surface area and building code, you kind of came up with this project. A certain percentage of each wall had to have windows or doors. It had to cover a certain footprint of and then each wall and each section of the roof was actually printed flat and then stood up. It was a neat way to bring 3D printing into some of the core classes. So my next moves, this was kind of me writing late last night my ideas down, but I would recommend a do-it-yourself printer if you have a real interest for it and you want to take the time to problem solve and research. It might not be the best option for regular classrooms where you want to get right to printing, because you do run into a lot of hiccups and there's not that support at Staples or one of these other big box stores. My next steps are really to involve in maintaining and fixing the printers, and that just comes from a lack of time on my part. And also, one of the ideas of building these printers was to teach students how electronics work. Your cell phone, and not many people can tell you how it works. It just works. So this whole maker mentality and breaking things apart and tinkering is a good way to find out how our new technology world around us works. I might want to spend some more time with a refined printer after seeing some of those projects that were printed downtown. And I do have a couple printers on the way. They're called Onos, and these are SLA printers. So SLA printing actually uses it uses light to cure the resin. And these ones fit over top of your cell phone. So with an app in your phone, you could it slices your image into 2D images, and then over time, and I don't have them yet, so I can't really speak to this, but you could print the entire volume of these little cartridges with different objects, and it might be a neat way for kids to explore the different technologies, as well as having some immediate results with their designs. And then also I'm really interested in exploring CNCs and laser cutters, both for how they can support the 3D printing and how they can support the different parts of different curriculums, primarily in the core classes is what I'm really interested in pursuing. Is my presentation. I could show you guys just I'll go quickly here. I know we're getting short on time, and I want to give Tony the chance to talk. Stop screen sharing here. This is just the cart. Sorry if I don't want to be too shaky for you guys. These are the different printers I've worked with, and they both have heated beds. They're works in progress. I put them on wood frames or wood bases, as it helps keep the printer square and stable. And much like Aaron's, one of the printers there, 3D printed some parts to put the spools up top. I did that more for just maintaining desktop space. Couple of the little projects off Thingiverse, but it was neat to see.
Please excuse this interruption. Mr. Linskus has asked that the grade 7 boys Highland Sirs, your meeting today at 3:15 in room 17. So Highland Sirs, you're in room 17 at 3:15. Thank you.
Sorry. And last 5 minutes of the day, they're making their announcements. So this was just a way of combining nuts and bolts and 3D printed parts and created a little universal joint. I thought that was interesting. Some other botched prints that apparently, if you heat up the plastic, you can really bend it into any shape you want to. So maybe more of a medical application with wrist brace and that sort of thing, printing them flat on your bed and then putting them in boiling water and being able to play with them that way. So, and just some figurines and other things kids have printed. So I'm going to stop there. Again, if you have any questions or if we just want to move on, then thanks for listening to my spiel.
Okay, thank you so much. We're going to hold the questions to the end. And I'm going to switch it over to Tony. So Tony, thank you for waiting so long. But it is yours.
No worries. Our bell is going to go in about 3 minutes here, so I'll start talking and kind of pause for that when it happens. But just to let everyone know who I am, I'm a junior high teacher at Dan Knott School. I teach a bit of math, a bit of technology, and a bit of soccer here. And I attended Jason's building workshop last year, which is how our school got started with 3D printing. And so we picked up 2 printers. One worked pretty quickly after we left the place. It wasn't working the second day, but pretty quickly we had it up and printing and working, and the kids are really excited about it. The second one is still in progress, and so I think, like Jason mentioned, it takes patience and working at it and figuring out what's wrong with it. But certainly the one printer that we've had running has generated a lot of interest with our students. I would say the thing that I like the most about our printers is our students that are involved in project-based learning have an outlet to really take their creativity and make what they see in their head. And so, you know, like Highlands, we're also involved with iCubed. And so last year and this year, I've had students come to me, not necessarily part of my tech classes, but have said, you know, I really want this design. Can I build this prototype, or can I build this piece? And so they're coming to me with ideas for things that they want to build, just being aware that we have a 3D printer, and they're willing to work with me to figure out how to make what it is that they want to do. So for our projects, it's been great. And so I stole a few of the science examples. Students had a science assignment project that had to do with making improvements to some kind of a machine. And so this group looked at a car and streamlining. Theirs actually didn't move, but this group actually made something that had gears that they 3D printed and a battery and wheels and the car body. And so they entirely 3D printed this design with a little motor, and they got it to work. I'm just going to close the door. So certainly for our...
Can I please get the following students to the office? Samiha Sayeda and Nisaya Ahmed. Thank you.
So certainly for our projects, I found the 3D printers to be really helpful. The other thing that I thought would be really important to mention is one of the questions was about how does this all fit into the curriculum? And, you know, with all the work that we've been looking at, the competencies and with the CTF curriculum, it all seems to fit together with the problem solving and the creating and the analyzing and fixing and applying new skills. And like what was mentioned before with the numeracy, lots and lots of numbers that seem to come up in the designs and the dimensions, in scaling things down and trying to make things fit together and how far apart they need to be. Lots and lots of numbers and visualization in terms of, you know, how am I going to fit these pieces together to make what I want, or how am I going to cut this out to make the space that I need to make. I certainly think that it fits in very well with, you know, the CTF outcomes and with the competencies. Like Jason, our students have been using Tinkercad quite a bit. In terms of printing, we've used something called AstroPrint, which requires a little bit of back and forth with SD cards, the way that our system is set up here. And so that tends to slow things down a little bit. You know, students will make a design and they will have to export it into AstroPrint, and then they'll have to slice it, and then they'll have to send it back and get it on the SD card, which they can eventually put into the printer. And so there's a bit of back and forthing there, which I'm trying to simplify to make it easier for the students. Because one of the things going forward that, you know, I would like to do differently is certainly to try and make the students more independent with using the printers. You know, for our school right now, the students are doing the designing and the creating, but ultimately all the print jobs are going through me onto the printer. And mostly because there seems to be a lot of, you know, just little things that I haven't, you know, taught the students yet in terms of leveling the printer, or, you know, how to troubleshoot if it, you know, or how to recognize that it's not printing properly and stopping it soon. You know, because it's, you know, it's disheartening for the kids to get 3 hours into a print job and then figure out that it's not working properly or it's warping. And so far right now, all the print jobs are going through me, which makes it a little bit slow. And so going forward, you know, I would certainly like a system more where the students are going to be more independent for setting up the printer and getting those print jobs going, so that I can get on with my day and the things that I need to do with my other classes. And, you know, the printer can just be going in the background and the students can slip in and get the print jobs going. Let's see what else we have here. I could probably show some of the other prints that we've done. I showed you the two cars, and those are both from a science experiment. Last year, we also did a rocket experiment, and so my homeroom went looking for
Mr. Cannon, please call 221.
Different rocket pieces. And so we built pieces for a rocket to put onto a 2-liter bottle that we used some pumps and pumped up and sent up. And that was one way my students used it. We also invested in some circuit boards. And so we went onto Thingiverse and we found some different pieces so that we could mount our circuit boards inside of a nice protective case. So that's something that we've been able to do here at the school as well. Mathematics, I was able to build a nice little tower problem to model one of the ones that's in our textbook. Students have made rings. Students have made, this was a towers have Hanoi problem that the students built as one of my challenges. But I think that's all I've got to share for now. The only other thing I guess with our program here and what we've been offering is that our school this year, we have something called Flex. And Flex happens every Thursday, and our students get to basically pick their classes on those days. And so, you know, 3D design is something that I've offered, and it's been by far one of the most popular things. It fills up within the first 2 minutes of it being open on Fridays. The students get onto the Chromebooks, onto their phones, and sign up for their Flex sessions for the next week. And it's been very, very popular. So certainly just having the printer in the building and offering these types of opportunities to do designs and print things on the printer has generated a lot of interest in the school. So I think that's all I got.
Okay, thank you so much, Tony and Aaron and Jason and of course Dennis. Like it's been, I don't know, I expect everybody else would agree. Like I should show you, we have a lot of heads that are just kind of nodding up and down. There's like smiles of appreciation and waves, and we really appreciate you coming in. And I mean, I know as a teacher how busy lives are in the classroom with kids, and for you to put the time into preparing for this and being able to share your expertise with our group here. We appreciate it a lot. It's always a challenge, like to really like feel that we're connecting the dots between downtown and the schools, and this conversation, I think, has helped to do a lot of that, and it's pretty inspiring. Like for me, I expect for others too to feel that you guys have been going down this road like this, and now as we can kind of keep in touch and kind of touch base moving forward, we can start to grow like a really kind of intentional community moving forward with 3D printing in schools. So thanks again. We're going to see if they hang out on Airworked, and if so, we'll have this as an archive, and I'll share the link with you. So yeah, thanks again. Okay. Guess I'll say goodbye.
Bye.
Bye.
Thank you.